you'll see that the formulas are similar, of course, but different. We're still going to have to do area of the base. We're going to do perimeter of the base. There's going to be some new calculations in here, though. Let's start with pyramid. So you, of course, the red words, what you have to fill in on your notes. Pyramid is a polyhedron in which the base is a polygon. Right away, I'm already thinking half-app. It's going to be coming at me. Where the lateral faces are triangles and a common vertex called the vertex of the pyramid. The intersection, we talked about this yesterday on prism. The intersection of two faces, we call that an edge. And then, of course, we also have the vertex up here at the top. Now, it's not drawn on here, but I'm going to draw it because you're going to see it today. Height of the pyramid, how tall the pyramid is. So the height goes straight through the middle, and it's perpendicular to the base. Okay. Now, we're going to get a little more specific on our pyramid, and this section we're going to focus on what we call regular pyramids. Now, regular, we've seen that word before, means all the sides are congruent. So we're going to focus on a regular pyramid where we have a regular polygon for the base, which you can see in this very lovely picture here. And of course, the segment joining the vertex and the center of the base is perpendicular. The lateral faces of a regular pyramid are congruent isosceles triangles. So here's what's different. When you have this very lovely, this would be a square, regular polygon base, all of these faces, all the sides are congruent isosceles triangles. We're on the last one, for instance. I mean, this is not a regular base, it's a rectangle, okay? So that's why it's kind of like not perfectly, it's kind of shoved to the side. It's not perfectly perpendicular up and down in the middle. We're going to be focused on regular pyramids. Excuse me. You're also going to need, here's the new part, the slant height. So there's two different heights you have to know in a pyramid for the formula. One, you have just the plain normal height, the straight through the middle of the pyramid. This is the new one. The slant height is the height of one of the triangular faces. So that is going to be part of the formula. If you have your green sheet, you might already see it. They use this lowercase cursive L for it. So we're going to have to find that, or we're going to need that today. That's kind of the new calculation from yesterday, from a pyramid, of course, from a prism. So the formula. You got to fill in the formula there. Fill that in. Surface area of a pyramid. Now, of course, a lot of the letters mean the same thing as yesterday. B, capital B is the area of the base. You're going to have to know what the base is. Oh boy. If it's a square, you have to know how to do area of a square. If it is a hexagon, you have to know half-app. You have to know the formula for the base. P, of course, perimeter of the base, just like yesterday. The new letter is this guy. That lowercase cursive L. That is your slant height. So that's the new piece we're going to introduce to you in order to find these surface areas today. All right, let's do it. Now, just so it's in front of us, I'm going to put the formula up here. Area of the base, half times the perimeter of the base, slant height. And you know, I always start with the base. I always find that's the hardest and takes the most work, so I like to just get it done with. All right, look at the pyramid for me. Easy question. What shape is the base? Base is a what? Square. Because it's regular. We got to know, how do you find area of a square? It's the same as area of a rectangle. That helps. Length times width, or base times height, or it's a square. You could just do side times side because they're the same. Well, our sides are 16. So I'm going to do 16 times 16. All right, multiply that out. 16 times 16, 256. Now, we also need the perimeter of the base. Okay, all right, well, that's going to be easy. It's a square, and they're all sides are 16. So what's the perimeter of the base? 64, thank you, Ty. I would just do 4 times 16. Or you could do 16 plus 16 plus 16 plus 16. Okay, next thing we're going to need is the slant height. Look at the picture. Do you know the slant height? Okay, here's the glitch. So just so I don't have it in the way, let me erase all my writing here. Let's take a look at how we're going to do the slant height. So you can see they kind of have it labeled here. I'm just going to put it right on the picture. And I see this very sneaky right triangle in here. So I'm going to work off this right triangle. I'm going to draw it out here so we can see it a little bigger. So we want to find the slant height. They're telling you there's an arrow here that this is 15. And I've got half of the square-sided base. So if the whole base is 16, half of it. So you know 2 sides out of the 3 sides of a triangle. What theorem, again, are we using to find the missing side? Pythagorean theorem. Or it is the Pythagorean triple if you know it. I'm going to do 8 squared plus 15 squared equals L squared. Okay, what's 8 squared plus 15 squared? Punch that in your calculator. I don't expect you to do that in your head. 289. Thank you, Leona. Perfect. Let's get rid of the squaring with a root. What is the square root of 289? 17. Comes out nice. All right, we've got it. So guess what? We have everything we need now to do the final surface area calculations. Area of the base, 256, plus perimeter of the base. We found, or I need to put the half in. Perimeter of the base, 64, and then our slant height we just got. Punch that all in. I'll give you a second for your final answer. Leona's quick on the draw back there. 800, I'm going to label it centimeters squared. Love it. Okay, questions I can answer for you on this one, anybody? All right, cruising on. We're going to do a couple more pyramids. Cones are easy. We'll just do a couple of those. Now, same thing. I'm going to write the formula at the top just so it's in front of us. Clearly, it's on your formula sheet. Okay, let's start with the base. That's always the hardest part, or the most time-consuming, I should say. Easy question for you. What shape is the base? Hexagon. I'm just going to abbreviate. So what formula are we going to use to find the area of that regular hexagon? Our favorite best friend formula that keeps coming up. Half. I heard it. Okay, so I'm already cringing a little bit, but maybe not. Do you know the apothem? Yeah, yes, winning. So my apothem is right here from the center to the middle of a side. Can you get the perimeter with hardly really any work? I think so, because we know the sides are 10. It is a hexagon. There's 6 of them. What's 6 times 10? 60. All right, punch that in. Let's get the area of the base. I rounded to the 10th. I round everything to the 10th. I know Leona's got it back there. I can tell her by her facial expression. Somebody else besides poor Leona. Who's got it? Got it. Thank you. Okay. I think we're in pretty good shape here. So let's see what we got. So area of the base, I just figured that out. Plus a half. Perimeter of the base, we did that earlier. That was the 6 times 10. I'm just going to steal that one. All right, take a look at the picture. Do you know the slant height? Remember, the slant height is the height of one of the triangular sides. And we sure do. I see you nodding yes. Right there. 14. Got it. All right, punch that in your calculator, which I know you can do. You should end up with 679.8. I'm going to label it. Okay, questions I can answer on that guy. All right, one last pyramid, and then I'm going to show you cone. Cone is very simple, I promise. Okay, pyramid. Let's write the formula again. I just like it in front of us. You've got it. So let's start with the base, of course. As always, what figure is the base? This time it's a what? How many sides? Pentagon. So once again, half-half, that regular polygon formula. All right, let's see what they were nice or mean to us here. Take a look at the picture. Do you know the apothem? Do you know from the center to the middle of a side? Yep, right there, 5.5. Thank you, picture. Can you, just probably in your head, get the perimeter of the base for me? Yeah, it's 5 sides, and each side is what? 8. What's 8 times 5? 40. Okay, multiply that out in your calculator, of course, and you should get 110. Okay, all right, so I'm going to put 110 in here for area of the base. We got perimeter of the base, 40. I'm going to steal that, of course. Now, question. Do you know the slant height? No, we were doing so good. Okay, but I see we have this triangle here, and that's our slant height on the side. I'm going to kind of redraw it out here. I got some room to write on it. But I think we're going to be able to do this with not a lot of work, because you have this labeled as 4.8, and I drew out half of the, we know they've got this labeled here as the 5.5. So they've got those labeled for you. 2 sides out of 3, once again, not a shock, Pythagorean theorem, here it comes. So I'm going to do 5.5 squared plus 4.8 squared equals the hypotenuse squared. All right, you definitely need a calculator for that. This is not a nice one. Punch that in, see if you can get the slant height. See what you get. I feel like we need some Jeopardy music playing. Let's see who's first to get it. Slant height. What's your final answer just for the slant height? 7.3. That was quick, Ted. So now I'm going to put 7.3 in here. Okay, final answer. What is the whole calculation for the surface area? I like this very robotic too, Ty. You are correct, 256 meters squared. I love it. Okay, questions on pyramid. Now, don't forget, in geometry, the gift that keeps on giving. These pyramids were not too bad. You may still have to, let's go back to like those homework problems, just so we're clear here. Maybe, come on, smart board. So I'm about to yell at it. You have to maybe, maybe. Let me go back to 12. You might still have to get your central angle and use some SOHCAHTOA today for the apothem. That could still be in play on the homework, just to warn you. Warn sounds kind of ominous, but just so you're aware of that. All right, cones. Think about an ice cream cone. That's what it looks like here today. So a cone, of course, has a circular base, shocker, and a vertex that is not in the same plane as the base. So obviously the vertex is this point at the very top. Okay, that's exciting. Now, what we're going to be working on is a right cone. The segment joining the vertex and center of the base is perpendicular. So you have that right angle, of course, and you have the slant height. So slant height, again, is still in play, and you're going to see it in the formula. Now, it's kind of a similar formula, but I'm going to swap out that base, that capital B. What's the formula for area of a circle? Pi r squared. So when I click it to the formula, instead of starting with the b, I'm going to swap it out for pi r squared. And it's very similar, as you're going to see there in red. So you can see they kind of started with the same idea. Area of the base, pi r squared, because it's a circle, put that in. Now, circumference, of course, would be our 2 pi r, which simplifies to this, and then your slant height. So it's really working off the same formula. Just your base is a circle, and of course, perimeter is circumference on a circle. It's really the same, just with the circle stuff swapped into it. So let me give you a sec to write that down. And of course, that's on your green sheet too. Now, anytime you have anything circular, cone or cylinder, they're super easy, okay? Obviously, I know you know, but you're gonna need the radius from the center to the edge. And then of course you can see the slant height here listed. All right, let's do it. Find the surface area of the right cone. Okay, let's do it. So I'm already looking at the picture, thinking about my formula. What do I know? So area of the base, pi r squared. Well, you know the radius. Look at the picture. What's the radius? 6. So I'm going to do pi times 6 squared. There's the area of the base. Now, the next part of the formula, times pi times radius times the slant height. Okay, glitch, you don't know the slant height. That would be, of course, this hypotenuse on the right triangle. But 2 ways you can do it. Maybe you know, because I did say it earlier on purpose, I know my Pythagorean triples. 6, 8, 10. If you're like, dude, I didn't know 6, 8, 10 is a triangle, use Pythagorean theorem. This is going to give you 100, and then when you square root it, you're going to get 10. I just know my triples. Okay, punch that in your calculator, see what you get. Ty's probably already got it. We should all be trying to type it in to make sure we can type it in our calculator correctly. Because I swear every year I have some poor kid set this up perfect and then it goes off the rails on the calculator. I don't want that to be you. So punch one in for me. And I rounded to the tens. And your answer should start with a 3. All right, what do you got? I see you guys writing. Ty, hit it. Perfect. All right, one last cone problem of the day to end it off. Here we go. Same thing. And I'm like, oh man, I'm looking at the picture. Do you know the radius? Do you know the slant height? Okay. All right, I gotta do some work before I get crazy on my surface area formulas. I'm not scared because I'm gonna make this one easy. You have, if this is 60, this has to be 30. We are on our 30, 60, 90 triangle. Now, could I use SOHCAHTOA? Sure, but I'm not. That's too much work. I'm going to use my lovely 30, 60, 90 knowledge and plus so I can review it because why not? Okay? So, we always want to find the short leg. Unfortunately, you do not have that. The short leg is across from 30. They gave you the long leg. Now, to get the long leg, focus here. You usually do the short times. I said that for dramatic emphasis. Times the square root of 3. So if I'm doing the opposite, I'm not going to times by the square root of 3. I'm going to what? Divide. So I'm going to do 18 divided. You don't even have to rationalize. Just punch that in your calculator. Give me the decimal. What is that? Punch it in. What do you got? What do we have? Because I'm going to start coughing. 10.4. So that's this side. Now, somebody can not cough through it. I'm going to get the hypotenuse super easy. I double the short side. What's 10.4 double? Okay, we have everything we know. Let's do it. So, pi r squared. What number is the radius? Lena's right, 10.4. Plus pi times that radius again, times the slant height. What number is the slant height? 20.8, I heard it. All right, type it in for your final answer. This one's kind of big. Starts with a 1. All right, what do you got? 1,019.4. And I'm going to label, and we got it. All right, questions on that guy? So your homework, again, similar as last night's front and back. Today it's all pyramids and cones. Keep your green sheet handy. And of course, tomorrow we shall mix them all together.